Tonight, we're going to try something ambitious. Not with a spacecraft, not with futuristic technology, just with imagination. We're going to begin exactly where you are right now, in the place you're sitting, listening, breathing. And then, step by step, we'll move away from Earth, crossing distances that grow wider and emptier, until we reach the very edge of the observable universe. And along the way, I want you to notice something important. Not a number, not an equation, but the true feeling of scale. You've heard this phrase countless times. The universe is vast. It's true, and yet it's almost meaningless. Saying the universe is vast is like saying the ocean is wet or fire is hot. Technically correct, but completely inadequate. Because the universe isn't just big. It's so unimaginably enormous that the human mind was never designed to truly comprehend it. Your brain evolved to judge the distance to the nearest river, to estimate the height of a tree, to decide whether a predator was close enough to be dangerous. We never needed to imagine distances measured in millions, billions, or trillions of miles. And yet, tonight, we're going to try. Before we begin, if you enjoy this kind of slow, quiet exploration, a quick like or subscription helps this journey continue. For you, it's just a click. For me, it's an entire universe of motivation. Now then, let's begin with the most familiar place of all, the human scale, the world you know. Take a moment and look around the room you're in right now. Maybe it's a bedroom, a living room, a quiet corner where you work or think. The walls are somewhere between a few feet and maybe 30 feet away from you. This is the kind of distance your brain handles effortlessly. You don't need to measure it. You don't need to calculate anything. You simply feel it. You know exactly how far it is to stand up and cross the room. You know how many steps it would take. You've done it so many times that the distance barely registers as information at all. You've walked through rooms like this thousands of times in your life. So often that your brain has completely automated the experience. This space is familiar, safe, human. Now, gently expand that picture. Think about the entire home you're in, or the building, the rooms connected by hallways, doorways, staircases, paths you could navigate even in the dark, half asleep, without really thinking. Maybe it's a small house. Maybe it's a large apartment complex or an office building. Either way, the total distance from one end to the other might be a few dozen meters, maybe a few hundred. Still small, still manageable, still deeply within the scale your mind evolved to understand. These are distances tied to muscle memory, to habit, to routine. Your body knows them as well as your thoughts do. Now, in your imagination, step outside. Think about your street, your neighborhood, the sidewalks you've walked, the turns you make without checking a map, the places you recognize instantly, the cafe you stop at without thinking, the store where you already know which aisle you need, the intersection that always feels busy at the wrong time of day. This is the geography of your daily life. Your world might stretch a few kilometers in every direction, maybe more, maybe less. But it exists in your mind as a clear, intuitive map. You know where things are relative to each other. You know which routes are faster, which ones feel longer than they really are, which shortcuts save you time. This is still a human-scaled world. Now zoom out again. Consider your city or town as a whole. The place you might cross in 30 minutes, or an hour, or maybe more, depending on traffic. You don't know every street anymore, but you understand the structure. Downtown is over there. Residential areas spread outward this way. Major roads cut across everything like arteries. This is the largest scale most people interact with regularly, and even here, your brain is still comfortable. You can imagine crossing it. You can imagine the time it would take. You've done it before. Now think bigger. Think about your country. If you were to travel from one side to the other, it would take days. maybe weeks depending on how you move. The landscapes would change. Cities would blur into countryside, forests into plains, plains into deserts, mountains into coastlines. It's a long journey, a serious distance, but it's still something humans routinely do. People make these trips every single day, by car, by train, by plane. Even at this scale, your mind can still grasp it, because it's built from smaller pieces you already understand. And then there is the Earth itself. A sphere nearly 8,000 miles wide, 25,000 miles around its equator, large enough that most people will never see all of it, but small enough that we have mapped every continent, crossed every ocean, photographed it in its entirety. We've walked on it, sailed across it, flown above it. The Earth feels enormous when you're standing on its surface, but it is, ultimately, a place you belong to. Everything up to this point, your room, your neighborhood, your city, your country, your planet, exists within a scale your mind was designed to handle. This is the world your intuition understands, and this is where that intuition is about to break. Because everything you've imagined so far, every distance you've felt, every journey you've ever taken, is still unimaginably small compared to what lies beyond. The city, the nation, the Earth. Now think about the city or town where you live. It might stretch 20 kilometers from one side to the other, maybe 50, maybe 80 if it's a large metropolitan area. You don't know every street anymore. You couldn't name every neighborhood or memorize every intersection, but you understand the structure. You know where the center is. You know which directions lead outward. You know which roads carry the most traffic and which ones people avoid during rush hour. You can drive across your city in an hour, maybe less, maybe a little more on a bad day. It's large enough to feel complex, but still small enough to feel familiar. Now, let your perspective pull back even farther. Think about your country. If you live in the United States, the distance from the East Coast to the West Coast is roughly 3,000 miles, about 4,800 kilometers. If you were to drive that entire distance without stopping, no sleep, no meals, no breaks, it would take close to 40 hours of continuous motion, almost 2 full days behind the wheel. In reality, of course, no one does it that way. People spread the journey across days, sometimes weeks. They watch the landscape change slowly as they move. Forests give way to open plains. Plains stretch into deserts. Deserts rise into mountains. And eventually, the land falls away into ocean again. It's a long journey, an exhausting one, but it's not impossible. Millions of people make cross-country trips every year, by car, by train, by plane. The distance is great, but it's still something the human mind can grasp, because it's built from pieces we already understand. Cities, highways, hours, days. Now think about the Earth itself, the planet beneath your feet. A sphere roughly 8,000 miles wide. A world with a circumference of about 25,000 miles, around 40,000 kilometers. If there were a road that followed the equator perfectly, and you could drive it without ever stopping, it would take nearly 2 full weeks of continuous driving just to complete a single loop around the planet. 14 days. Day and night, no rest. These are enormous distances, truly enormous, and yet they are still within the limits of human understanding, because we've been everywhere. We've crossed every ocean, mapped every continent, climbed the highest mountains, sailed around the world, flown above it. We've seen our planet from space, a blue sphere hanging in darkness. The Earth feels vast when you're standing on its surface, but it is, ultimately, a place we know. It is our home. Everything up to this point, from the room you're in, to the streets you walk, to the city you cross, to the nation you traverse, to the planet itself, exists within a scale the human mind was shaped to handle. Our intuition still works here. Our sense of distance still makes sense. We can imagine these journeys, we can feel the time they take, we can relate them to our own experience. But from here on, that sense begins to fail. Because beyond Earth, the distances no longer grow by hours or days or even weeks. They grow by something else entirely. And once we leave our planet behind, we leave the human scale with it. The Moon, our nearest neighbor. When we finally step away from Earth, the first stop on our journey is something you've seen almost your entire life: the Moon. It hangs in the sky like a quiet companion, always there, familiar, so close that your senses insist it must be nearby. On a clear night, you can see dark patches spread across its surface, bright streaks radiating outward from ancient impacts. With a simple pair of binoculars, individual craters come into view. It feels reachable, almost within arm's length. But that feeling is an illusion. The average distance from Earth to the Moon is about 384,000 kilometers, nearly 240,000 miles. To understand what that actually means, imagine driving your car straight upward into space. If you traveled at highway speed, about 110 kilometers per hour, and you never stopped, never slept, never slowed down, it would take you almost 5 months of continuous driving just to reach the Moon. 5 months to arrive at something that appears to be hanging right above your head. Even with the most powerful machines humanity has ever built, the distance is humbling. When the Apollo astronauts made the journey, they rode rockets that accelerated them to nearly 40,000 kilometers per hour. Speeds no human had ever experienced before. And even then, it still took about 3 days to cross that gap. 3 days spent drifting through silence. No air, no sound, no sense of motion at all. Just Earth slowly shrinking behind them, and the Moon growing larger ahead. Here's a comparison that helps place the distance into human terms. If Earth were reduced to the size of a basketball, the Moon would be about the size of a tennis ball. But it wouldn't be hovering right next to it. It would be sitting almost 7 meters away, across an entire living room, on the far side of the space. Not close, not intimate, separated by a vast stretch of emptiness. In fact, the space between Earth and the Moon is so enormous that every other planet in the solar system, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, could fit neatly in between them. All of them, with room to spare. That empty gap is real space, not a diagram, not an illustration. And it's that space that makes the Moon so important. Because the Moon is the farthest place humans have ever physically traveled. Out of all the billions of people who have lived on Earth, only 12 have ever stood on another world. And that other world was this one, our nearest neighbor. When those astronauts spoke to mission control back on Earth, their words didn't arrive instantly. Even radio signals, traveling at the speed of light, took more than a second to cross the distance. You can hear it in the recordings, the pause, the delay, a reminder that even here, even this close, space is already vast. The Moon feels like it belongs to Earth, like it's part of our immediate environment. But in cosmic terms, it is already far away. And it marks a boundary, because once you pass the Moon, you leave behind every place humans have ever touched. Everything beyond this point is known only through instruments, mathematics, and light. We've sent machines farther, signals farther, our understanding farther, but our footsteps end here. And from this distance onward, the universe stops feeling familiar. The Moon may be our closest neighbor, but it is already the edge of human reach. Light and delay, when distance becomes something you can feel. When astronauts spoke to Earth from the Moon, there was always a brief pause, not because they were searching for the right words, not because they were confused or uncertain, but because light needs time to travel. Even at the fastest speed the universe allows, a radio signal still takes more than a second to cross the empty space between Earth and the Moon. Just over 1 second there, just over 1 second back. You can hear it clearly in the recordings. A question is asked, then silence, then a reply. A tiny gap, barely noticeable at first, but once you know it's there, you can't stop hearing it. That pause is distance made audible. On Earth, we're used to instant response. Voices travel through air so quickly that conversation feels immediate. Even when you speak to someone on the other side of the planet, fiber optic cables and satellites hide the delay. Milliseconds pass, but your brain barely registers them. Everything feels now. But space does not work that way. In space, distance reveals itself. It refuses to stay invisible. The Moon is close by cosmic standards, and yet even here, the universe already demands patience. Light, the fastest thing that exists, cannot cheat the distance. It does not hurry. It does not take shortcuts. It simply moves, and arrives when it arrives. That 1 second delay may sound insignificant, but it represents something profound. It means the Moon is not right there. It means Earth and Moon are already separate worlds, connected only by beams of light crossing emptiness. And this is just the beginning. As distances grow, those pauses stretch longer. If you could somehow watch Earth from the Moon, you wouldn't see it as it is now. You would see it as it was more than a second ago. Every cloud slightly out of date. Every flash of lightning already finished. Every movement already past. Space is not only distance, it is time. And light is the messenger that binds them together. Now imagine moving farther away. At twice the distance, the delay doubles. At 10 times the distance, 10 times the waiting, the universe begins to introduce a new rule. Nothing happens instantly anymore. Cause and effect are separated. Action and response drift apart. Distance stops being abstract and starts becoming something you can feel. This is where intuition begins to struggle. Because our lives are built on immediacy, we expect reaction, feedback, response. Space offers none of that. It stretches the present, it pulls moments apart. And light, no matter how fast it moves, can only bridge that gap 1 second at a time. That brief silence between Earth and Moon is the smallest taste of what's coming. Because once we leave our nearest neighbor behind, the delays stop being seconds. They become minutes, hours, days. Eventually, they become years. At that point, you're no longer communicating across space. You're communicating across time. Messages arrive long after the moment has passed. Replies return to a world that has already changed. This is the true scale of distance, not measured in kilometers or miles, but in waiting, in silence, in the realization that the universe does not revolve around now. The Moon taught us that even the closest places are far, and light taught us something even more unsettling. The universe has a speed limit, and nothing, not matter, not energy, not information, is allowed to exceed it. From here on, distance will no longer just be something we imagine. It will be something we experience. In pauses, in delays, in the slow, unavoidable passage of time between one place and another. The Sun, the first real leap. Now turn your attention inward, toward the center of our star system, the Sun. A single star that contains about 99.8% of all the mass in the entire solar system. Everything else, the planets, the moons, the asteroids, the comets, is little more than debris left over from its formation. The Sun is the source of nearly all energy on Earth. Every breath you take, every ocean current, every gust of wind, every living cell. It rises every morning, it sets every evening. So reliably, so predictably, that it feels close, familiar, as if it were just beyond the sky. But the Sun is not nearby. The average distance between Earth and the Sun is about 93 million miles, roughly 150 million kilometers. That distance is so fundamental to astronomy that it has its own unit of measurement. 1 astronomical unit, 1 AU. This is the baseline, the ruler we use to measure the solar system. And from this point forward, the numbers your intuition relies on begin to lose their meaning. Imagine driving toward the sun. At highway speed, about 70 miles per hour, it would take you more than 150 years of non-stop driving to arrive. No brakes, no sleep, no slowing down. 150 years to reach the star that warms your face every day. Even at the speed of a commercial jet, it would take decades. And light, the fastest thing that exists, still needs time. Sunlight takes a little over 8 minutes to reach Earth. That means the light touching your skin right now left the sun 8 minutes ago. If the sun were to vanish this instant, an impossible thought, but imagine it, you wouldn't know right away. The sky would remain blue, the world would stay warm, birds would continue flying. For 8 full minutes, everything would seem normal. And then, without warning, darkness would arrive. That delay is not a technical detail. It is a fundamental feature of reality. It means the sun you see is never the sun as it is now. It is the sun as it was. Space does not show you the present. It only shows you the past. At the scale of the moon, that past was just over a second ago. At the scale of the sun, it is 8 minutes old. Already, the universe is pulling the present apart. And yet, in another sense, the sun is still close. Because this enormous distance that already breaks intuition, is only the beginning. Within the solar system, 1 AU is considered small. Mercury orbits closer in, Venus slightly farther out, Mars farther still. The outer planets exist at distances measured in tens of astronomical units. Even so, the sun's gravity dominates everything. Its influence stretches far beyond the orbit of the planets, holding the solar system together like an anchor. But mentally, this is the moment where scale truly changes. Because for the first time, we are no longer talking about a place you could ever hope to reach in a human lifetime. We are no longer measuring journeys in days or weeks or months. We are measuring them in generations. The sun marks the boundary between distances that feel difficult and distances that feel impossible. It is the first step where your intuition completely fails to keep up. The moon was far, but it was still a destination. The sun is different. It is not a place you imagine visiting. It is something you orbit, something you depend on, something you can never approach too closely. From here on, space stops being a collection of destinations and starts becoming a structure, a system defined by gravity, time, and light. And this first real leap from Earth to the sun sets the stage for everything that follows. Because beyond the sun, the distances do not increase gently, they explode. And once again, what feels enormous now will soon seem impossibly small. The planets, where distance begins to shatter. From the sun, let your attention move outward to the familiar names you've known since childhood. Mercury, Venus, Earth, Mars. In textbooks and diagrams, they're often drawn close together, lined up like marbles on a page, their orbits neat and compressed, so everything fits inside the margins. Those images are useful for learning names, but they are profoundly misleading. In reality, the planets are spread across an enormous emptiness, a volume of space that is almost entirely nothing. Even here, near the sun, distance is already breaking apart, the way your mind wants to picture things. Take Mars. Mars is often described as Earth's nearest neighbor, the next planet out, the most reachable destination beyond our world. But Mars is not close, because planets do not sit still. They move. They circle the sun at different speeds, on different paths. Sometimes Earth and Mars are on the same side of the sun, relatively near one another. At their closest approach, Mars is about 56 million kilometers away. That sounds large, but it's the best-case scenario. At other times, Mars is on the opposite side of the Sun. Then the distance stretches to more than 400 million kilometers. Same two planets, wildly different separation. At the closest distance, light takes just over 3 minutes to travel from Earth to Mars. At the farthest distance, that same light needs more than 22 minutes, and light is moving as fast as the universe allows. Now imagine communication. If you send a message to Mars at its closest, you wait 3 minutes for it to arrive. Then you wait another 3 minutes for a reply to come back. 6 minutes of silence for a single exchange. At the farthest distance, the waiting becomes almost unbearable. 22 minutes for your message to arrive, 22 minutes for a response to return. Nearly 45 minutes for a single question and answer. There is no conversation, no back and forth, no interruption, no clarification. Only long stretches of silence broken by delayed echoes. You speak, and then you wait. This is what distance really does. It doesn't just stretch space, it stretches time. Mars already exists in a different rhythm than Earth, a different tempo of cause and effect. And Mars is still close by solar system standards. Venus, when it's on the far side of the Sun, is even more distant. Mercury disappears entirely into solar glare, and as you move outward, the gaps grow larger. Between Mars and Jupiter lies an expanse so vast that it contains the asteroid belt, millions of rocks scattered through a space that is still mostly empty. Jupiter orbits more than 5 astronomical units from the Sun, 5 times further than Earth. Saturn nearly doubles that distance. Uranus doubles it again. Neptune pushes it even further. Each step outward does not add a little space, it multiplies it. The solar system is not a crowded neighborhood. It is a sparse archipelago of tiny worlds separated by oceans of vacuum. From planet to planet, distance is no longer something you travel across casually. It becomes something you endure, something you plan around, something that defines what is possible and what is not. This is where human intuition truly begins to fail. Your mind wants to imagine the planets as places that are near or far. But those words stop working here, because the solar system is not built for closeness. It is built for stability. Wide orbits, vast gaps, immense separations that allow gravity to keep everything in balance. From here on, distance is no longer just a number. It is delay. It is isolation. It is the slow realization that even within our own stellar backyard, nothing is truly nearby. And yet, all of this, Mars, Jupiter, Neptune, the farthest reaches of planetary orbits, still exists within a single star's domain. We have not left the Sun's influence. We have not yet reached the edge. And if these distances already feel overwhelming, what comes next will make them feel small. Because beyond the planets, space does not simply continue. It opens. The gas giants, worlds beyond imagination. Move farther outward, past the rocky worlds we can at least picture, and you enter a very different part of the solar system. This is where the gas giants begin. Jupiter, a planet so massive that it contains more material than every other planet combined. A sphere of gas and storms large enough to swallow more than 1,300 Earths and still have room left over. If Earth were reduced to the size of a marble, Jupiter would be a basketball. Its gravity is immense, its storms are ancient. The Great Red Spot, a single hurricane, has been raging for centuries and is larger than our entire planet. And yet, for all its size, Jupiter is not the most astonishing thing about this region of space. Because Jupiter is far. Jupiter orbits the Sun at a distance of about 5 astronomical units, 5 times farther from the Sun than Earth is. Light, moving at the fastest speed allowed by the universe, takes over 40 minutes to travel from the Sun to Jupiter. 40 minutes just across empty space. If you stood on Jupiter's cloud tops and watched the Sun, you wouldn't see it as it is. You would see it as it was nearly an hour ago. Now go farther. Saturn, a planet famous for its rings, vast, luminous bands of ice and rock stretching hundreds of thousands of kilometers into space. They look solid and monumental, but they are astonishingly thin. If Saturn was shrunk down to the size of a basketball, its rings would be thinner than a sheet of paper. A cosmic illusion. Delicate, fragile. Saturn orbits nearly 9.5 astronomical units from the Sun. At that distance, sunlight is weak, cold. Light now takes over an hour to reach this world. An hour of nothing between star and planet. And still we are not done. Beyond Saturn lie Uranus and Neptune, ice giants, remote, dim. Uranus circles the Sun at roughly 19 astronomical units, Neptune at about 30 times farther from the Sun than Earth. Here, sunlight is a faint glow, more suggestion than presence. At Neptune's distance, light takes over 4 hours to travel from the Sun. 4 hours for a single ray of light to cross the void. By the time it arrives, the Sun it carries is already long out of date. This is where distance truly stops behaving intuitively. Between these worlds are gaps so large that entire planetary systems could fit inside them. Nothing fills the space. No scenery, no landmarks, just darkness, cold, silence. The gas giants are not just big planets, they are markers. Each one represents a dramatic step outward where space stretches faster than your imagination can follow. From Earth to Mars, distance grows by minutes. From Mars to Jupiter, it grows by tens of minutes. From Jupiter to Neptune, it grows into hours. And with each step, human experience falls further behind. These are not places you imagine visiting casually. They are not destinations. They are thresholds. Beyond the gas giants, the solar system begins to thin out. The Sun's warmth fades, its influence weakens, and the distances stop feeling merely large and start feeling hostile. This is the outer solar system, a region defined not by worlds, but by the immense emptiness between them. If the inner planets taught us that space is wide, the gas giants teach us something far more unsettling. Space is not scaled for life. It is not scaled for intuition. It is scaled for gravity, for motion, for time. And the farther you go, the clearer that becomes. Because even these enormous planets, Jupiter, Saturn, Uranus, Neptune, are still close to the Sun, cosmically speaking. They still belong to its domain. And yet, if these distances already feel impossible to hold in your mind, what lies beyond them will erase any remaining sense of scale you thought you had. Because past the last giant planet, the solar system does not end gently. It dissolves into darkness. And from there, space truly begins. The edge of the solar system, the Kuiper Belt. Beyond Neptune, the solar system does not end. It fades. The neat architecture of planets gives way to something far more diffuse, far more ancient. We enter the Kuiper Belt, a vast, cold region of space filled with countless remnants left over from the earliest days of the solar system. Chunks of ice, fragments of rock, frozen debris drifting in the dark. Not clustered together, not forming anything recognizable at a glance, but spread thinly across an enormous volume of space. This region begins just beyond Neptune's orbit and stretches outward for billions of kilometers. And it marks a fundamental shift. Up until now, the solar system has felt structured, organized. Planets on predictable paths, clear orbits, a sense of order. The Kuiper Belt is different. It is not a line, not a ring you could draw cleanly on a diagram. It is a thick, uneven disk surrounding the Sun, tilted, warped, and sparsely populated. Most of it is empty. So empty that even here, objects rarely come close to one another. This is where Pluto resides. For decades, Pluto was counted among the planets. Then it was reclassified, not because it suddenly became smaller, but because we realized something important. Pluto is not unique. It is one of many. One of countless icy worlds occupying the distant outskirts of the Sun's domain. Pluto was never demoted because of its size. It was redefined because of its neighborhood. Because here, at this distance, the solar system begins to blur into something else. Pluto orbits the Sun at an average distance of nearly 40 astronomical units, 40 times farther from the Sun than Earth. At that distance, sunlight is weak and cold. Light leaving the Sun takes more than 5 hours to reach Pluto. 5 hours crossing nothing. If you stood on Pluto's frozen surface and looked up at the sky, the Sun would no longer look like the Sun. It would be a bright star, sharper than the others, but only slightly. It would no longer warm you. It would not dominate the sky. It would simply be the brightest point among many. Daytime on Pluto is dim, twilight-like. Shadows are long. Temperatures plunge far below anything experienced on Earth. And yet, even here, the Sun's gravity still holds. Pluto is still bound, still loyal to its star. It takes Pluto 248 Earth years to complete a single orbit. A full year on Pluto is longer than the entire span of modern human history. Civilizations rise and fall before Pluto finishes one lap around the Sun. This is the timescale that now accompanies distance. Hours become years, years become centuries. The Kuiper Belt represents a boundary not drawn with a sharp line, but with thinning influence. The Sun still rules here, but its grip is weakening. Objects move more slowly, orbits become less orderly. Perturbations from passing stars begin to matter. The solar system is no longer a compact system of worlds. It is becoming a cloud of leftovers. And this region is enormous. The Kuiper Belt contains millions, perhaps billions of icy bodies. Most will never be seen directly. They are too small, too dark, too far away. They exist as hints, as gravitational whispers, and beyond them, the spacing grows even wider. The Sun's warmth fades further, its light continues to weaken, and the idea of a planetary neighborhood starts to lose meaning altogether. The Kuiper Belt is not the end of the solar system, but it is the end of familiarity. Beyond this point, the solar system stops feeling like a collection of places and starts feeling like a gradual surrender to interstellar space. We are still home, but only barely. And as we move farther outward, the Sun, which once filled our sky, once defined our days, shrinks into just another star in an ocean of stars. From here on, the solar system does not announce its boundary, it simply lets go. The Oort cloud, how far the solar system really goes. Farther still, beyond anything we can see directly, lies something stranger than planets or belts or orbits. A hypothesis, a shadow, a structure we infer rather than observe. The Oort cloud. It is not a ring like the Kuiper Belt. It is not a disk. It is not flat. It is a vast spherical halo of ice surrounding the Sun in every direction. A shell of frozen remnants left over from the formation of the solar system itself. If the planets are the city and the Kuiper Belt is the distant suburbs, then the Oort cloud is the wilderness beyond the horizon. And it is enormous. The inner edge of the Oort cloud may begin thousands of astronomical units from the Sun. The outer edge may extend tens of thousands of astronomical units farther. So far out, that distance stops being measured in AU and starts being measured in light years. The outer boundary of the Oort cloud could lie more than 1 full light year from the Sun. 1 light year, that means light. Traveling at nearly 300,000 kilometers per second would need an entire year just to cross that distance. This is not poetic exaggeration. It means the solar system does not end where the planets end. It does not end where Pluto or the Kuiper Belt ends. It continues outward until the Sun's influence finally dissolves into the gravity of other stars. To understand what this means, consider something familiar. The distance from Earth to the Sun, 1 astronomical unit, is the yardstick of our intuition. That distance already felt immense, but the Oort cloud stretches tens of thousands of times further than that. What you once thought of as the entire solar system, the Sun and its planets, turns out to be just the dense central core. A bright island surrounded by an almost inconceivably vast sea. The Oort cloud contains trillions of icy objects, not clustered, not organized, drifting slowly, barely bound. Each one is a relic from the birth of the Sun, a frozen memory of the early chaos when planets were still forming and gravity was flinging debris outward in every direction. These objects move so slowly that a single orbit around the Sun can take millions of years. Millions. A comet born in the Oort cloud may begin its fall inward before human civilization exists and reach the inner solar system after it is gone. This is where many long-period comets come from. When a passing star drifts too close, or when the subtle tides of the Milky Way tug just enough, one of these distant objects is disturbed. Its orbit shifts, its long fall begins, and thousands or millions of years later, it appears in our sky. A brief visitor, a streak of light. We see it for days or weeks and call it spectacular. But its journey began before our species had language. That is the scale we are dealing with now. The Oort cloud is not something you picture easily. There are no landmarks, no familiar shapes. From inside it, the Sun would be indistinguishable from the other stars. Just another point of light. At that distance, the Sun's warmth is gone. Its light is faint. Its gravity still reaches, but only barely. This is the threshold, the place where the solar system stops being a dominant structure and starts being just one gravitational influence among many. Beyond the Oort cloud, there is no clear boundary, no wall, no edge you cross and declare, "Here ends the Sun's domain." There is only gradual loss. The Sun's grip weakens. The influence of neighboring stars grows stronger. Interstellar space begins not with a line, but with ambiguity. This realization changes everything, because it means the solar system, the thing you learned as a neat diagram of planets, is not a compact system at all. It is vast, diffuse, mostly empty. Its true size is not defined by where planets orbit, but by how far gravity and history still reach. And that size is staggering. The solar system spans a region of space large enough that light itself needs years to cross it. We live deep inside it, near its center, in a warm, dense pocket where distances feel manageable, but most of it lies far beyond our intuition. Cold, silent, almost untouched. The Oort cloud is the solar system's true frontier. Not because it is dramatic, but because it reveals the truth. What we thought was the whole story was only the beginning. And even this enormous, year-wide halo of ice, is still just one star's territory. One bubble in a galaxy filled with hundreds of billions more. If the planets taught us that space is wide, and the Kuiper belt taught us that it fades, the Oort cloud teaches us something deeper. Home is much larger than we ever imagined. And yet, in the context of what comes next, it is still impossibly small. The nearest star, the first truly shattering leap. Up to this point, everything we've talked about, the planets, the Kuiper belt, the Oort cloud, still belonged to one system, one star, one source of gravity, one home. Now we leave it. The nearest star to the Sun is called Proxima Centauri. It sounds close, nearest always does, but the distance to Proxima Centauri is about 4.24 light years. Not kilometers, not millions of kilometers, not even billions. Light years. A unit that no longer measures space alone, but time itself. It is the distance light travels in more than 4 years, moving at the fastest speed the universe allows. To put that in perspective, Light can circle the Earth more than 7 times in a single second, and even at that speed, it needs over 4 years to reach this nearest star. If you were to leave the outer edge of the Oort cloud and head toward Proxima Centauri, you would not cross a border into another system. You would cross an ocean of nothing. The fastest spacecraft humans have ever built, objects like Voyager 1, move at tens of thousands of kilometers per hour. Impressive by human standards, insignificant by cosmic ones. At that speed, a journey to Proxima Centauri would take more than 70,000 years. 70,000 years. That is longer than recorded human history, longer than agriculture, longer than cities, longer than writing. Civilizations would rise and fall, languages would be born and forgotten. Entire species could evolve and disappear before such a journey was complete. And that's just to reach the nearest star. This is the moment where scale truly breaks. Inside the solar system, distances were vast but still connected. Planets belonged to the sun. Objects were bound, moving together through space. Between stars, that structure collapses. The distances do not gently increase. They explode. The space between stars is not filled with planets or debris or anything meaningful. It is almost perfectly empty. If you were to shrink the sun to the size of a grain of sand and place it on a scale model, the nearest grain representing Proxima Centauri would be kilometers away, with nothing in between. No scenery, no landmarks, no sense of movement, just darkness. This is why interstellar space feels so different. It is not just far, it is isolating. The sun's gravity no longer dominates. Other stars tug faintly from afar. The galaxy's tides begin to matter. You are no longer inside a system, you are between systems. And here, distance stops being something you imagine crossing. It becomes something that defines reality itself. Even communication becomes meaningless. A radio message sent from Earth would take more than 4 years to reach Proxima Centauri. A reply would take another 4 years to return. Nearly a decade for a single exchange. Not a conversation, a historical record. By the time a response arrives, the world that sent the question may already be unrecognizable. This is why the gap between stars is not just far, it is empty to the point of absurdity. Empty in a way that defies intuition. Empty in a way that makes motion irrelevant and patience meaningless. And yet, Proxima Centauri is still a neighbor. In galactic terms, 4.24 light-years is nothing. The Milky Way galaxy is over 100,000 light-years across. Our nearest star is barely a step away on that scale, which leads to a disturbing realization. If the jump from the Sun to its nearest stellar neighbor already feels impossible to comprehend, then everything that comes next will dwarf it completely. The leap between stars is the first time the universe stops feeling large and starts feeling indifferent. This is where you understand that space is not built for travel, not built for life, not built for convenience. It is built for vastness. Proxima Centauri is not just a destination, it is a warning. A warning that the universe is not a collection of nearby places, but a scattering of isolated islands separated by gulfs of nothingness so wide that even light must struggle to cross them. And this first staggering gap between stars is only the beginning, because once you step into the galaxy itself, the distances no longer grow by years, they grow by tens of thousands. And the idea of near disappears entirely. The galaxy, our home. The sun is not special. It feels important to us because it gives us light and warmth, because everything we know depends on it. But in the larger structure of the universe, the sun is an ordinary star, one among many inside a much larger system, the Milky Way galaxy. Our galaxy contains somewhere between 100 and 400 billion stars. That range alone should tell you something. Even after centuries of observation, we still cannot count them precisely. They are packed into a vast rotating disk held together by gravity, threaded with spiral arms, wrapped around a dense central core. The Milky Way is about 100,000 light-years across. That means light, moving at the fastest speed the universe allows, takes 100,000 years to travel from one side of our galaxy to the other. To put that into perspective, modern humans have existed for only about 300,000 years. Light could cross the galaxy only 3 times during the entire history of our species. This is the scale of the place we live in. If the solar system were reduced to a single grain of dust, the Milky Way would not be a room, or a city, or even a country. It would be an entire continent, and that comparison still understates it, because most of that continent is empty. The stars are spread far apart. On average, the distance between neighboring stars is measured in light-years. Between them lies darkness, thin gas, occasional dust. The galaxy is not crowded, it is sparse. And within this enormous structure, we are not at the center. We are not near the core, where stars are packed tightly together and gravity dominates everything. We live in a quiet suburb. The Sun is located in one of the Milky Way's spiral arms, far from the center, about 27,000 light-years away from the galactic core. That means when we look toward the center of the galaxy, we are looking 27,000 years into the past. The light reaching our eyes tonight left those central stars long before the first cities were built on Earth. The Milky Way itself is ancient. It formed more than 13 billion years ago, shortly after the universe came into existence. Stars have been born and died within it for billions of years. Entire generations of suns have lived out their lives, exploded, and scattered their elements into space before our planet even existed. Every atom heavier than hydrogen in your body was forged inside stars like these. Supernovae seeded the galaxy with the raw materials of planets, of oceans, of life. We are not separate from the Milky Way, we are a consequence of it. And yet, despite its size, despite its hundreds of billions of stars, the Milky Way is only one galaxy. It is not the center of the universe, it is not unique. It is one island of stars among countless others. From a distance, the Milky Way would look like a faint spiral of light, one glowing disk among billions. All of human history, every war, every discovery, every moment of love and fear has taken place on a single planet orbiting a single star in the outer regions of one ordinary galaxy. That realization can feel unsettling, but it can also feel grounding, because it tells us something important. We are not lost in the universe. We have an address. We belong to a structure vast beyond comprehension, shaped by gravity and time, filled with stars that came before us and stars that will outlive us. The Milky Way is our home, not because it was made for us, but because we emerged within it. And as enormous as it feels, as overwhelming as 100,000 light-years may seem, it is still only a beginning. Because beyond the edges of our galaxy, space does not end, it opens. And what lies beyond the Milky Way will make even this, our entire stellar continent, feel small. Nearby galaxies, when the universe begins to multiply. Until now, everything we've talked about has existed inside a single galaxy, hundreds of billions of stars, a structure 100,000 light-years wide. That already feels overwhelming. But now we step outside it. The nearest large galaxy to our own is Andromeda. On clear, dark nights, you can actually see it with the naked eye, a faint, elongated smudge in the sky. Easy to miss. Easy to mistake for a cloud. But that faint glow is not small. It is an entire galaxy. Andromeda lies about 2.5 million light-years away. Not kilometers, not billions of kilometers, light-years. The light reaching your eyes from Andromeda tonight began its journey 2.5 million years ago. At that time, modern humans did not yet exist. Our ancestors were still primitive, using simple tools, barely distinguishable from other hominins. Civilization was unimaginable. Language itself was still forming. And yet, that ancient light has been traveling ever since, crossing intergalactic space, arriving only now. You are not seeing Andromeda as it is, you are seeing it as it was long before humanity. Andromeda is not standing still. It is moving. It is falling toward us. The Milky Way and Andromeda are bound by gravity, locked in a slow, inevitable dance. They are approaching each other at hundreds of kilometers per second. In about 4 billion years, they will collide. Not a violent crash like cars on a highway, but a slow interweaving of stars. Galaxies passing through one another, their shapes distorting, their orbits reshaping. The night sky will change beyond recognition, and after billions more years, the two galaxies will merge into a single, larger system. This is not speculation, it is mathematics. This is the future of our home, and Andromeda is only one neighbor. The Milky Way does not exist alone in space. It is part of a small community called the Local Group, a loose collection of dozens of galaxies held together by gravity. Large spirals like the Milky Way and Andromeda, smaller dwarf galaxies orbiting them like companions. Some are faint and diffuse, some a little more than clouds of stars. All of them separated by distances measured in hundreds of thousands to millions of light years. Between these galaxies is almost nothing. No planets, no stars, just thin gas, occasional stray particles, and vast emptiness. Intergalactic space makes the space between stars look crowded by comparison. This is where scale truly begins to replicate itself. Stars become common, galaxies become common. What once felt unique becomes repeated. Patterns emerge, spirals, ellipticals, clusters. The universe starts to feel less like a place and more like a process. The local group itself is only a tiny part of something much larger. It sits on the outskirts of a vast cosmic structure, a filament of galaxies stretched across hundreds of millions of light years. We are no longer talking about isolated systems. We are talking about a universe built from repetition. Galaxies arranged in groups, groups arranged in clusters. Clusters woven into enormous filaments surrounding vast, empty voids. The universe is not scattered randomly. It has structure, on scales so large that even galaxies are just building blocks. And here is the unsettling part. Everything we have discussed so far, the Sun, the Milky Way, Andromeda, the entire local group, all of it fits comfortably inside a region of space that is still considered small, cosmically insignificant. The jump from stars to galaxies was enormous. The jump from galaxies to clusters will be worse, because once the universe begins to multiply itself, once galaxies stop feeling special, distance no longer just increases, it compounds, and the familiar idea of nearby dies completely. Andromeda feels unimaginably far, but in the language of the universe, it is close, a neighbor. And if a galaxy 2.5 million light years away is considered nearby, then what lies beyond will push your sense of scale past anything it has ever held before. Because from here on, the universe does not just grow. It repeats itself on a canvas so vast that even galaxies become points of light lost in the dark. Clusters and superclusters, the true structure of the universe. As we keep pulling back, one of the most surprising truths about the universe finally comes into focus. Galaxies are not scattered randomly through space. They are not sprinkled evenly, like stars painted across a dark ceiling. They gather. They form groups. Those groups form clusters, and clusters themselves link together into structures so vast that the human mind was never meant to visualize them. This is where the universe reveals its true architecture. A single galaxy, like the Milky Way, is already immense, a collection of hundreds of billions of stars bound together by gravity. But galaxies themselves are social structures. They rarely exist alone. Most belong to clusters, gravitational cities of galaxies, containing hundreds, sometimes thousands, of individual galaxies orbiting a shared center of mass. Within these clusters, galaxies move slowly, drifting past one another over billions of years. They collide, they merge, they are stripped, stretched, and reshaped. Clusters are chaotic places, dense, active. And yet, even clusters are not the largest pattern. Clusters themselves are arranged into something even bigger, superclusters. These are not tidy objects with clear boundaries. They are sprawling regions of space where clusters of galaxies are loosely connected along immense filaments. These filaments stretch across hundreds of millions of light years. They weave through the universe like cosmic highways, connecting dense nodes of matter across unimaginable distances. Between these filaments are voids, and this is where intuition truly fails. Cosmic voids are not empty in the way space between planets is empty. They are emptiness on a scale that borders on the absurd. These regions can span tens, hundreds, sometimes even billions of light years across. Inside them, there are almost no galaxies, no clusters, no structure, just thin gas, dark matter, and an overwhelming absence of everything else. Light can take hundreds of millions of years to cross a single void. Hundreds of millions. That means when light enters one side of a cosmic void, entire species can rise and go extinct before it ever reaches the other side. From a distance, the universe resembles something strangely familiar. Not a cloud, not a solid, but foam. Like giant soap bubbles pressed together. Dense walls and filaments surrounding vast, empty spaces. A cosmic web. This structure did not form by chance. It is the result of gravity acting over nearly 14 billion years. Tiny differences in density in the early universe were amplified over time. Regions that were slightly denser pulled in more matter. Regions that were slightly emptier lost what little they had. Over billions of years, matter flowed along invisible paths, collecting into filaments and nodes, leaving behind enormous voids. The universe organized itself on the largest scales imaginable. What is most unsettling is how small familiar things become at this level. A galaxy cluster, which once seemed impossibly large, is now just a bright knot on a much larger thread. A supercluster, which can contain tens of thousands of galaxies, is still only one feature in a web that spans the observable universe. There is no center to this structure, no preferred direction. Wherever you look, the same pattern repeats. Filaments, nodes, voids. The universe looks this way from every vantage point, which means something profound. Our location is not special. The Milky Way does not sit at a crossroads of the cosmos. It sits on one filament among countless others, in one supercluster among many. All the stars we see in the night sky, all the galaxies revealed by telescopes, are embedded in this immense, almost invisible framework. And here is the final shift in perspective. At this scale, even galaxies stop being the main characters. They become tracers. Tiny lights outlining a structure defined mostly by things we cannot see. Dark matter, dark energy, and gravity itself. This is the universe, not as a collection of objects, but as a system. A living pattern shaped by time, expansion, and attraction. And as vast as clusters and superclusters are, as overwhelming as this cosmic web may feel, it is still not the whole story. Because even this structure, this foam of galaxies and voids, exists inside something larger. A boundary set not by matter, but by time itself. And beyond that boundary, distance takes on a meaning unlike anything we have encountered so far. This is the scale where the universe stops feeling like a place and starts feeling like an event. And that is where our journey is heading next.